Hello everyone, my name is Manisha and you're watching our YouTube channel Punishka tutorial. In my last video, we have learned about natural numbers, whole numbers, integers, fractions. Then we started with our main concept, that is rational number. We have seen what you actually mean by a rational number, difference between fraction and a rational number, properties of rational number, how to bring rational number which is given into its standard form, and how to compare the two given rational numbers. In today's video, we will apply those concepts in some examples. In our first example, we are supposed to find out three equivalent rational numbers equivalent to 2 upon minus 5. To find equivalent rational number, we have to multiply the rational number with some integer m. Here I am considering 3 in the first step. 2 upon minus 5 into 3 is equal to 6 upon minus 15. Whatever the integer value you are considering, you have to multiply the same number with numerator and denominator. In the second step, I am considering a negative integer 2 upon minus 5 into minus 2, which is equal to minus 4 upon 10. Similarly, we get the value 10 upon minus 25. So 6 upon minus 15, minus 4 upon 10, 10 upon minus 25 are equivalent rational numbers of 2 upon minus 5. Here I have written fractions, okay. Intentionally I have written this to tell you that as the denominators are negative in these cases, in 6 upon minus 15 and 10 upon minus 25, it's not a fraction. Do not get confused. If the denominator is negative or the numerator is negative, then it's a rational number and not a fraction, because fraction is a ratio of two natural numbers, okay, and natural numbers are always positive, whereas rational numbers are ratio of two integers which can be positive as well as negative. So these are rational numbers and not fractions. Let's continue. This is our second example in which we have to check whether the two given rational numbers are equivalent or not. Suppose there are two rational numbers p upon q and r upon s. If these two rational numbers are equivalent, then p into s is equal to q into r. That means if the product of p into s and q into r are equal, this means that p upon q and r upon s are equivalent rational numbers. We will apply same rule in this example. 8 upon 12, 6 upon 9, we will multiply 8 into 9. 8 into 9 is 72. 12 into 6 is also 72. Both the values are equal, and hence 8 upon 12 is equivalent to 6 upon 9. Next example, 12 upon 9 and 7 upon minus 6. We'll multiply 12 into minus 6, we'll get the value as minus 72. 9 into 7 is 63. Okay. Both the values are different. Minus 72 is not equal to 63. This means that 12 upon 9 is not equivalent to 7 upon minus 6. Here I would like to give you a small trick, a small tip. If you are writing exam or if you are solving any sums in your school, then in case if you make some mistake, do not scribble like this. You just have to put a single strike so that the paper, the solution looks little bit neat and clean. Let's solve the next example. Here we have to express 3 upon 10 with numerator 9. That means we have to find a rational numbers whose numerator is 9 and which is equivalent to 3 upon 10. 3 upon 10 is equal to 9 upon some denominator d, which we have to find out. If you compare the numerator, because we have to find the denominator, we will compare the numerator value. The given rational number is 3 upon 10, its numerator is 3, and the rational number's denominator that we have to find, it has a numerator 9. We will compare 3 and 9. The value of numerator is increased, okay. In that case we will multiply. If the value is getting increased, in that case we will multiply. If the value decreases, in that case we will divide. In our example it is increasing, so we will multiply. 3 into some number is equal to 9. We should multiply some number to 3 to get 9. So that number is 3. 3 3s are 9. So In numerator, we have multiplied numerator with 3 to get 9. Same in integer will multiply to the denominator as well. 3 into 10 is 3 into 3 is equal to 9. 10 into 3 is equal to 30. So 9 upon 30 is the required rational number, and 30 was the denominator that we were supposed to find out. Then in our next example, we have 30 upon 75. We have to express this as a rational number with denominator 15. Okay. Here denominator is given and we have to find out the numerator. If you compare the denominators, the first rational number has denominator 75 and the second rational number has denominator 15. This means that the denominator value is getting decreased. In this case, we will consider division. Now compare 75 and 15. We have to divide 75 with some number to get value 15. If you observe, we divide by 5 to get 15. Okay, when we divide 75 by 5, we get the value as 15. So we will divide the numerator of the first rational number with the same number, that is 5. 30 divided by 5 is 6. So we got 6 upon 15. 6 is the required numerator and 6 upon 15 is the required rational number. In this example, you have to find the value of x such that 6 upon minus 7 becomes equivalent to x upon 42. Okay, in this case, both the denominators are given, so we will compare the denominators. Minus 7 and 42 is there. The value of the denominator is increasing, so we will multiply. We have to multiply minus 7 with some number to get 42. If you observe, we multiply minus 7 with minus 6 to get 42. We will multiply the same minus 6 to the numerator. 6 into minus 6 is equal to minus 36 and minus 7 into minus 6 is equal to 42. So minus 36 is the required numerator or the value of x, and minus 36 upon 42 is the required rational number. Now let us see how to find absolute value of a rational number. Let us see how do you find absolute value of any integer. Absolute value of a negative integer is always positive. Absolute value of positive integer is positive. This means that absolute value of minus x is x, absolute value of x is also x, and absolute value of 0 is 0. Absolute value of any integer is its numerical value without considering its sign. Similarly, we see how do you find absolute value of a rational number. If our rational number is in the form of p by q, then absolute value of p upon q will be p upon q. Absolute value of minus p upon q is p upon q. Absolute value of p upon minus q is also p upon q. That means absolute value of both the positive and the negative rational number will always be positive. Absolute value of 0 is 0. Absolute value of every rational number other than 0 will be positive. Absolute value of 0 will be 0, and absolute value of a rational number is always greater than or equal to the number itself. Now let us see different methods to compare two given rational numbers. First method, 4 upon 7 minus 6 upon 7. If you see, both the denominators are same in this example, so we will compare only the numerator part. 4 is greater than minus 6 and thus 4 upon 7 is greater than minus 6 upon 7. Second method, we have to compare 3 upon 5 and 7 upon 13. In this example, you have to keep in mind that both the rational numbers are positive. This method will work only when the given rational numbers are positive rational numbers. In this case, the denominators are different. Okay, so the denominator, the rational number with smaller denominator is always greater. If we compare the denominator of these two rational numbers, 5 is smaller than 13 and hence 3 upon 5 is greater fraction. 3 upon 5 is greater than 7 upon 13. Remember that this method will work only when we are dealing with positive rational numbers. Now let us see the third example, third method of comparing the rational numbers. Minus 3 upon 5 is given and minus 4 upon 6 is given. Both the denominators are different, so we will compare like this. If we have two rational numbers p upon q and r upon s, we use the butterfly method, or also known as the cross multiplication method, and we'll find the product of P and S and Q and R. If P into S is greater than Q into R, this means that P upon Q is greater than R upon S. We have to keep in mind that order of multiplication does matter. Here we have to consider the product of P into S on left hand side. You cannot write this as Q into R and P into S. You have to consider P into S first. We have to keep P into S in the LHS and the product of Q into R in the RHS. If P into S is greater than Q into R, P upon Q is greater than R upon S. If P into S is smaller than Q into R, this means that the rational number on the right hand side is greater. P upon Q is smaller than R upon S. And if both the products are equal, P into S is equal to Q into R, both the rational numbers are equivalent. Coming back to our example, minus 3 upon 5 minus 4 upon 6, we will multiply and find the product of minus 3 and 6. Minus 3 into 6 is minus 18. 5 into minus 4 is minus 20. Minus 18 is greater than minus 20, and therefore minus 3 upon 5 is greater than minus 4 upon 6. Let us see few more examples. 3 upon 5 and minus 14 upon 6. Here the product of 3 into 6 is 18, 5 into minus 14 is minus 70, 18 is greater than minus 70, and thus 3 upon 5 is greater than minus 14 upon 6. Next example, minus 15 upon 7 and minus 14 upon 13. We'll multiply and find out the product of minus 15 and 13. Minus 15 into 13 is minus 195. 7 into minus 14 is minus 98. Minus 98 is greater than minus 195, and therefore minus 14 upon 13 is greater than minus 15 upon 7. Next example, 15 upon 7 and minus 14 upon 13. 15 into 13 is 195, 7 into minus 14 is 98, 195 is greater than 98, and therefore 15 upon 7 is greater than minus 14 upon 13. Now let's see the fourth method to compare the two given rational numbers. Minus 5 upon 7 and 9 upon minus 13 is given. Both the denominators are different, and the denominator of the second rational number is negative. First we will make the denominator positive. So we get the rational numbers as minus 5 upon 7 and minus 9 upon 13. Then we will find the HCF of the denominators. In this example, both of them are prime numbers. So HCF will be 7 into 13, which is equal to 91. Now we will make the denominators as 91 and will find the corresponding numerator. Minus 5 upon 7, when we multiply it with 13, we will get the denominator as 91 and the numerator will be minus 65. Same way, minus 9 upon 13 will multiply this rational number with 7 and will get the result as minus 63 upon 91. Now both the denominators are same. We will compare the numerator part, minus 65 and minus 63. As we all know that minus 63 is greater than minus 65, this means that 9 upon minus 13 is greater than minus 5 upon 7. If you have any doubt in these concepts, please comment it in the comment section. Thank you.